Hey everyone, in this video I'm going to walk you through instance connectivity with EC2. So I'm going to show you a couple of ways how to connect to your EC2 instances. One is using Instance Connect, including if you want to connect into instances in a private subnet using an endpoint. I'm also going to show you the most secure method of connectivity, and that is using Session Manager. I'm going to do hands-on for both of those. So firstly, let's just cover off a little bit of theory. So there's a few different ways you can connect to your instances. The first one is you're going to use a key pair and you're going to leverage the SSH protocol. Or if you're on Windows, you can either install the SSH client or you can use the PuTTY utility. Now for this, all operating systems support SSH, and you're going to connect using a terminal CLI connectivity to the instance. It uses an SSH daemon. That's actually the process running on the server side. Now you do need to assign a key pair. A key pair is using public key cryptography, and so basically there's a public key and a private key. The public key is on the instance, the private key is a file that you download. Now these are long-term credentials essentially. That means that there is a security risk here. If somebody compromises your private key, they can access all of your instances, so not particularly good. Now you do need to have port 22 open for SSH. Anyone with that key pair can access the instance if they have that private key. Now the next one is RDP for Windows instances. Then of course you get a desktop, a visual environment. It uses the remote desktop service on the server side. You need an RDP client as well. I use a Mac, so I have to install one. If you're using Windows, then it's usually installed by default. And again, we need ports open. So port 3389 must be open on the server. And here you're using a username and password to log in. Now the next one, we're going to practice with this one, is EC2 Instance Connect. Supports all operating systems. Again, it's leveraging the SSH protocol and the SSH server component running on your instance. It generates the key pair for you, and these are temporary. So now rather than those long-term credentials, which are a security risk, the temporary key pairs are created on the fly behind the scenes. You don't really see them, but it's done for you automatically. So a bit more secure, but you still need port 22 open on your instances. So not ideal, not the best way, but it's very convenient. So we'll have a look at how to use the Instance Connect feature. And you can get some access control capabilities through IAM as well. The last one is Session Manager. I think this is probably the most secure way. It does require the SSM agent installed on the actual instance. So that's the Systems Manager agent. So Session Manager is a feature of AWS Systems Manager, and you need the SSM agent. If you're using the Amazon Linux AMIs, then it will already have that agent installed for you. And the permissions are actually automatically created for you these days. You used to have to assign certain policies to using a role to your instances, but now it's kind of done behind the scenes, so it's a lot easier. And there is IAM access control capabilities there as well. No ports are open. That's the good thing here. Session Manager will enable you to access Windows and Linux instances using either a command line environment into Linux, and it's using actually remote PowerShell for Windows as well. So in both cases, it's a command line. And there's some access control capabilities through IAM as well. So Session Manager is a really good way of accessing your instances using a command line without opening any ports. So let's look at Instance Connect. Instance Connect is where we're deploying our instances in subnets, can be public or private. And then we're connecting from the EC2 Instance Connect service. It is leveraging the SSH protocol to connect. For the private subnets, you won't be able to connect by default. You have to deploy the EC2 Instance Connect endpoint. That's going to set up an endpoint with an elastic network interface in your private subnet, and then you can connect through to your private instances as well. We're going to look at how we can do both of these things. Okay, so I'm in the console here. I'm going to first open the VPC service because I'm going to create a temporary VPC which I'm going to use just for these labs. So I'm going to simply go over to your VPCs, create VPC. I'm going to use the VPC and more function. I like this. It really just is a very easy way to set things up. I'll call this SSH Lab. Now I'm going to leave the default CIDR block. It's fine, that's okay. It does overlap with another one I think in my account, but I don't care because I'm never going to connect this to any other VPCs using transit gateway or VPC peering. We're just going to use this for a few tests and then I'm going to delete it. It's going to create these 4 subnets, so 2 public, we've got 1 public in each of these availability zones and 2 private, 1 in each AZ as well. And some route tables, network connections, internet gateway, all of that stuff gets set up. You can configure those settings by changing the number of AZs you want, number of subnets, and so on. The only thing I'm going to do is just turn off the VPC endpoint for S3. I don't need that for this lab. And let's create the VPC. That's going to very quickly create my VPC configuration for me. If you create a NAT gateway, it's going to take a few minutes longer. I didn't create a NAT gateway for this one. So let's go back to View VPC. We can see everything is set up. We've got some subnets in here now as well. Let me just refresh that. There we go. We've got our public and private subnets nicely labeled for us. So now we're going to launch instances. And what I'm going to do is just use the Amazon Linux AMI. And I'm going to launch one into a public subnet and one into a private subnet within that custom VPC. I don't need key pairs because we're not using key pairs here. We're going to use first EC2 Instance Connect and second Session Manager. So let's head over to Instances, Launch. I'll call this one public so I know which one it is. And it's going to be the Amazon Linux. Currently it's the 2023 AMI, just whatever the latest AMI is when you're watching this video. T2 Micro. I don't need a key pair, which is good. I do need to change my network settings. So I'm going to change my network settings here to use my SSH Lab VPC. And for this one, this is my public instance, so I do want to make sure that it's going into a public subnet. And it's not giving me a public IP by default because that's actually not part of the setup when you're using that VPC in More Wizard. So I actually have to change to enable. And I'm going to create a security group. Let's call this SSH-lab. And I'll just copy that down also into the description just to make life a bit easy. And it's going to be, we need one rule here. So we're going to use SSH and it's going to allow from anywhere. That's fine. We do actually need that, by the way, for Instance Connect. So we need to have the SSH protocol enabled from anywhere because we don't know the source addresses that AWS is connecting from. So that's all I need to do for my public instance. Let's create that one. And then let's go back and I'm going to launch another one. And for this one, I'm going to call it private. And again, I'm going to leave some defaults up here, proceed without a key pair, and then change my VPC so that I can go and use the SSH Lab VPC. I don't need a public IP now because I'm going to put it into a private subnet. So let's go into private 1 here. And now I can select the existing security group and then just launch that instance. So that's all happening. Those instances are starting up. Now, once they're ready, we're going to be able to connect using EC2 Instance Connect. Now, I mentioned that's only going to work in the public subnet. It's not going to work for the private subnet because it does require a public IP. For the private instance, what we want to do is connect using an Instance Connect endpoint. Okay, it takes a few minutes to set that up. So what I'm going to do is just cancel out of there, go back to the VPC Management Console, click on Endpoints, and here we're going to create an endpoint, and I'll just call this my Instance Connect Endpoint. Could have chosen something smaller, but that's okay. And then I'm going to choose EC2 Instance Connect Endpoint. So you can see there's endpoints for lots of services. They basically give you private connectivity to those services which actually sit outside of your VPC. So I want to choose the EC2 Instance Connect option here, of course. I want to select my VPC, SSH Lab VPC. And then I need to select a security group. So we're going to use the SSH Lab security group here. And then for subnet, what I want to do, of course, is choose a private subnet. I'm going to choose private 1. That's where I deployed my instance. So once I've chosen those settings, I can create the endpoint. That's going to start creating. There's nothing else I need to do except wait for it to be active. Currently it's pending, and it does take several minutes. So while that's happening, let's come back to EC2. Here I can choose my public instance and I can click on connect. So we've got a few options, of course, for connecting here. The SSH client is when you have the public-private key, so you've got the key pair, you downloaded the private key, you have that available locally, and it gives you the instructions for connectivity. When you want to use this, of course, you have to choose the key pair when you first launch the instance, and then make sure that you've got the file, the .pem file locally. You'll need to run chmod or change the permissions through the properties on Windows. And then you can connect to your instance using its public DNS. And this is the whole command you need to do that. I'd recommend everybody uses the SSH client, by the way, rather than using PuTTY. That's my opinion. You can use PuTTY if you like. Now, the other one is Session Manager. We're going to come back to Session Manager. That's the most secure way without opening any ports. But for now, we're going to use Instance Connect. This is an instance with a public IP. So that means I can connect. Now you'll notice the username is populated for me, EC2-user. That's the user account that we typically log in that doesn't have too many permissions on the Linux instance. If you go to the SSH client, you see we're using the same user here as well. We're connecting to EC2-user @. Now you can connect as root if you wish. Let me just go back to the instance connect dialog here. You can just remove this and type root if you want to connect as root. I'm happy with EC2-user, so I'm just going to make sure that user is selected. Now, if you're running a different distribution of Linux, like you're running up an Ubuntu instance, for example, it's going to be a different user account. You'll have to refer to the documentation for that particular Linux distribution. So we've got EC2-user selected. Let's click on connect. And that's all there is to it. So I am now connected to my instance. I can run commands like ifconfig to see its IP address and whatever else you want to do on that instance. So I'm on the command line now. Now, if at this point it failed, it popped up with a red banner saying that there was a connectivity issue, what you're going to want to do is go back and check that you've got a public IP. You should do. If you get to that point, it's usually got a public IP, because otherwise it will tell you immediately when you try and open the Instance Connect console. So the next thing to do is go to your security group. Open up the security group that's attached to your instance, click on Edit Inbound Rules, and you just want to make sure you've got this rule, SSH from anywhere. It can't be from the security group itself, can't be from any specific IP ranges. It has to be from anywhere, because we don't know what the addresses are that we're connecting from, because the connection's coming from EC2 service itself. Okay, so that's done. We've connected successfully to this particular instance in the public subnet. So I can close that down. So we've connected successfully to our public instance. Now I want to try and connect to my private instance. That's the one here. I've got it nicely labeled. If I go to the networking tab, I can validate the availability zone and the subnet it's in. It's definitely in a private subnet. And that means, of course, it does not have a public IP. It only has a private IP and a private DNS name. So if I click on connect, we are instantly given this warning here, which is telling us the instance does not have a public IPv4 when we're trying to use Instance Connect. Okay, so there's no public IPv4, so that's not going to work. So we need to make sure that our endpoint is ready and then come back and use the Instance Connect endpoint when it is. Okay, I just refreshed my screen here. We can see that my endpoint is available. Now, if we have a look at the endpoint here, we can see, if we scroll along a little way, that it has a network interface. Now, that does mean that there will be a charge if you leave this running. It should be, I think it will be within the free tier for a while, but make sure that you consider that, because whenever the EC2 is launching these ENIs, or any service is launching an ENI for us, we know it's going to cost us some amount of money. Okay, so this is up and running. Let's come back to instances and choose my private instance and connect. And now we obviously can't connect using the direct instance connect, so we use the endpoint. And it's filled out the endpoint for me. Again, I can choose the user account. I'm going to leave EC2-user selected and then click on connect. So now I'm on an instance in a private subnet. If I try and ping google.com, it should not work, because of course we do not have public internet access. So we're leveraging that private connectivity. So that's what we've done. We've connected using SSH protocol directly from Instance Connect to the public subnet and then via an endpoint to the private subnet. So let's have a look at another way. So there's a product called Systems Manager. This helps you to manage your server infrastructure on AWS. Has quite a few different features. We've got automation, we've got run command, we've got inventory, patch manager, session manager, parameter store, incident manager, and state manager. Lots of different features. There's more than this as well. We're going to concentrate on session manager for now. So with session manager, we can connect to both Linux and Windows instances using a command line, and it's remote PowerShell for Windows. So it uses secure remote management without logging in or opening ports like 22 or 5986 for remote PowerShell. And it integrates with S3 and CloudWatch logs for logging and CloudTrail for auditing. So you can enable logging for Session Manager, and for example, you can direct those to CloudWatch logs, and every command that's run can be loaded into CloudWatch logs so that you can review the history of who did what and when. There's no longer any need for Bastion hosts or jump hosts. I think that's a legacy architecture, even predating the cloud. We used to connect into instances or servers in demilitarized or public-facing subnets, and then we'd be able to connect from those into the private subnets within the enterprise. In the case of the cloud, it means public subnets and private subnets, jumping from one instance that you can access publicly to another one that you can access privately. It's a bit of a legacy architecture. It's a bit, it's not the most easy to use either, and it's not the most secure. So much prefer to use Session Manager. With Session Manager, we also will need to deploy endpoints if we want to connect to the instances in private subnets. So for private subnets with Session Manager, there are a couple of VPC endpoints that you do need to enable to make this work. These are the three here for SSM, the EC2 messages, and the SSM messages. Same with Instance Connect, you just saw how to do that. We've connected an EC2 Instance Connect endpoint and utilized that to access instances in a private subnet. Okay, so let's go back to AWS and we're going to connect to an instance in a public subnet using Systems Manager Session Manager. Back in AWS, I need to open the Systems Manager service. Here it is. Let's open that one in a new tab. On the Systems Manager page here, you can see on the left-hand side, there's lots of different features. And I'm going to go down to Session Manager. Click on Session Manager. And on this page, I can connect to sessions straight away, or I can go and configure some preferences. Preferences include enabling CloudWatch logging or S3 logging. I've got CloudWatch logging enabled, so I've previously created a log group, and I've specified the log group here. And if you want that to work, you also need to add some permissions. You can look this up online. AWS document the whole process of enabling logging for CloudWatch here, and also adding the right permissions to your instances via an IAM role. So if I come back to the main page here for sessions, what I want to do is click on Start Session. We can see the public instance. We can't see the private instance because we didn't create an endpoint for Session Manager. That's fine. We're going to connect to the public instance, and I'm just going to click on Start Session. So here we go. This will open up a session, and we can see that we are logged in. If I just change up to my home directory, PWD, we can see that we're in SSM user directory. So that's the user that we've been logged in as. And we can run commands like ifconfig. We can see that this is the same instance we logged into earlier when we were using Instance Connect. But now we don't need ports open. So in fact, if I come back to EC2 and let's go and find our security group, I called that one, where is it, SSH Lab. Let's go to the security group, edit inbound rules, delete that rule and save. So now, guess what? We can still run commands. We are still actually on this particular server. I can still do things like, ping google.com. I haven't lost any connectivity here. That doesn't work. Let me type that correctly. There we go. We can still ping google.com. We haven't lost any connectivity to the command line here because we are using Session Manager, not using an SSH server. Now, you can either terminate the session here, or if you close it down, you can come back and you can see active sessions and then terminate them from the Session Manager console as well. So that's basically it. Now, Just before I finish this video, I will remind you that the endpoints do cost money. So if you finish with the configuration, don't forget to delete your endpoint. Of course, you'll want to terminate your instances as well. And once you've done that, once you've removed your instances and the ENI for the endpoint, then you'll be able to remove your VPC if you use the custom VPC like I did.